Good morning, students. Today we'll continue again with unit number 4 and topic number 3, which is cross-section of lined canals. It's an important topic, that is cross-section of lined canals. So cross-section of lined canals. In most cases, lined canals are designed as most economical sections. For most economical section, the hydraulic radius, that is capital R, should be maximum. Theoretically, a semicircular section is the best section for as open channel. However, it is not practicable to adopt this section. For practical consideration, a channel of trapezoidal or triangular section is usually selected. The corners of these sections are rounded to increase the hydraulic radius. The Bureau of Indian Standards Code IS 10430-1982 Criteria for design of line canals and guidelines for selection of type of lining, reaffirmed in 1991, recommends trapezoidal sections with rounded corners for all channels, small or large. So cross-section of line canals. In most cases, line canals are designed as most economical sections. For most economical section, the hydraulic radius, that is capital R, should be maximum. Theoretically, a semicircular section is the best section for as open channel. However, it is not practicable to adopt this section. For practical consideration, a channel of trapezoidal or triangular section is usually selected. The corners of these sections are rounded to increase the hydraulic radius. The Bureau of Indian Standards Code IS 10430-1982 Criteria for design of line canals and guidelines for selection of type of lining, reaffirmed in 1991, recommends trapezoidal sections with rounded corners for all channels, small or large. However, in India, the earlier practice had been to provide triangular channel sections with rounded bottom for smaller discharges. The geometric elements of these two types of channels are given below. The steps to be followed for selecting appropriate design parameters of a line irrigation channel according to IS 10430 may be summarized as follows. The first step is to select a suitable slope for the channel banks. This should be nearly equal to the angle of repose of the neutral soil. The steps to be followed for selecting appropriate design parameters of a line irrigation channel according to IS 10430 may be summarized as follows. The first step is to select a suitable slope for the channel banks. This should be nearly equal to the angle of repose of the neutral soil in the subgrade so that no earth pressure is exerted from behind on the lining. For example, for canals passing through sandy soil, the slope may be kept as 2h:1v, whereas canals in firm clay may have bank slopes as 1.5h:1v. Canals cut in rock may have almost vertical slopes. But slopes like 0.25 to 0.75h:1v is preferred from practical considerations. Step number 2. Decide on the freeboard, which is the depth allowance by which the banks are raised above the full supply level FSL of a canal. For channels of different discharge carrying capacities, the values recommended for freeboard are given in the following table. Type of channel: discharge in meter cube per second and freeboard in meters. Type of channel: main and branch canals greater than 10 and 0.75, branch canals and major distributaries 5 to 10 and 0.6, major distributaries 1 to 5, 0.50, minor distributaries less than 1 and freeboard is 0.30, watercourses less than 0.06 and freeboard is 0.1 to 0.15. Berms or horizontal strips of land provided at canal banks in deep cutting have to be incorporated in the section as shown in Figure 3. The berm and the natural surface level have already shown here. It is the figure of berms for canal banks at deep cutting. The berms serve as a road for inspection vehicles and also help to absorb any soil or rock that may drop from the cut face of soil or rock of the excavations. Berm width may be kept at least 2 meters. If vehicles are required to move, then a width of at least 5 meters may be provided. Step number 4. For canal sections in filling, banks on either side have to be provided with sufficient top width for movement of men or vehicles as shown in Figure 4. So here it is shown bank top width and also the natural surface level, and it is the figure of canal section in filling. The general recommendations for bank top width are as follows: discharge in meter cube per second and maximum bank top width in meters for inspection road and for non-inspection banks. Discharge is 0.15 to 7.5, for inspection road is 5.0, for non-inspection banks is 1.5. From 7.5 to 10.0 is 5.0 and 2.5. From 10.0 to 15.0 is 6.0 to 2.5. From 15.0 to 30.0 is 7.0 to 3.5. Greater than 30.0 is 8.0 and 5.0. Next, the cross section is to be determined for the channel section. Step number 5. Assume a safe limiting velocity of flow depending on the type of lining as given below. The first one is cement concrete lining, which is 2.7 meters per second, brick tile lining or burn tile lining, which is 1.8 meters per second, and boulder lining, which is 1.5 meters per second. Step number 6. Assume the appropriate values of flow friction coefficients. Since Manning's equation would usually be used for calculating the discharge in canals, values of Manning's roughness coefficient N from the following table may be considered for the corresponding type of canal lining. The surface characteristics and the value of Manning roughness coefficient is given below. So concrete with surfaces as formed or no finish or PCC tiles or slabs is 0.018 to 0.02. Trowel float finish is 0.015 to 0.018. United finish is 0.018 to 0.022. Concrete bed trowel finish with sides as hammered dressed stone masonry 0.019 to 0.021. Coarse rubble masonry 0.018 to 0.02. Random rubble masonry 0.02 to 0.025. Masonry plaster is 0.015 to 0.017. Dry boulder lining is 0.02 to 0.03 and brick tile lining is 0.018 to 0.02. Step number 7. The longitudinal slope S of the canal may vary from ridge to ridge depending upon the alignment. The slope of each ridge has to be evaluated from the alignment of the canal drawn on the map of the region. Step number 8. For the given discharge Q, permissible velocity V and longitudinal slope S, given side slope is less than and Manning's roughness coefficient N. For the given canal section, we have to find out the cross-section parameters of the canal, that is bed width B and depth of flow D. Since two unknowns are to be found, the two equations may be used, which are, first one is continuity equation, which is Q is equal to capital A into V, area into volume, and second is dynamic equation, which is V, that is volume is equal to 1 by N whole multiplied by A into R to the power 2 by 3 into S to the power 1 by 2. Here S is longitudinal slope and R is the radius as mentioned earlier, and A is the area. So that's all for today's class. Today we'll go through another video, and there is no assignment for this lecture, and now you can give your attendance in the chat box. Thank you all.